Video 4 in this series is going to cover break-even analysis. So let's look at what this might be. Well, companies definitely need to know the point at which they will realize a profit or a loss. So how much, when does my revenue exceed my costs where I realize a profit, and where does my revenue fall below my costs where I've actually spent more than I've made? When does that happen? Companies need to know this. Well, this point is known as the break-even point. And it is where either profit is zero. If you make no profit, that means that you've broken even. Or you can look at it in terms of revenue and cost, and it's where your revenue is equal to the cost. So as much money as you've brought in is the same exact amount of money that you spent. So you have broken even. You haven't gained any, you haven't lost any. The image over here at right shows how graphically this break-even point can be represented. Okay, so the break-even point in this instance is going to be over here. Oops, excuse me for that. Let's erase that. And we'll try that again. So the break-even point is going to be right here where they intersect. Right in here. All right, well, these two functions, these two linear functions that we have graphed here are actually functions that you found in section 1.1. So if we look back over here, recall from section, sorry for that typo, recall from section 1.1, we found the cost and revenue functions for a company that makes and sells dresses. What we found was that the cost function was 25x plus 80,000. That's this purple line right here. And you can see there's a little C right here. So that's the cost function. Just type that up in here so that you see that. And I'll make it in purple. So just to remind us, this is the cost function. And then we also found the revenue function. The revenue function was 75x, and that is this blue line. So we will put over here revenue. All right, when we graph both of these on the same coordinate plane, you see they've got different y-intercepts and different slopes, so you know they're going to intersect. Let's talk a little bit about where is the profit, where is the loss. So we know the break-even, the point at which they make no money, is right there at the point of intersection. Well, if we look over here, on this one, cost, on this side of the break-even point, cost is higher than revenue. All the y values on the cost function are larger than the y values over here on the revenue function. So when your costs exceeds your revenue, it's cost you more to make things than the amount of money that you brought in. This is where we realize a loss. So all of this area over in here, from the break-even point down in this area, all of this represents areas where we have realized a loss in the company. Well, vice versa, if we look over here on the other side of the break-even point, right here is where we see, the break-even point is the point where revenue now starts to become higher than the costs. So revenue has higher y values than the costs do, which means we actually then on this side realize a profit. I'll put it in black because sometimes that's what they refer to it as, is now we're in the black. So, oh, I didn't mean to put break. Sorry, profit is what I mean to put. Yeah, get rid of break. We'll move profit over in here. And then anything beyond that break-even point over there to the right, in between, that's bounded by these functions here, all of this is going to be where we realize a profit. And that's where revenue exceeds the costs. Okay, that's looking at it in terms of cost and revenue. If we want to look at it in terms of profit, we would have to do revenue minus cost. And then that point right here, way down here at that where it's zero, this is where profit should be zero. So the profit function, remember for profit, P of X it is revenue minus cost. So you'd have to take all of the blue line values and subtract the purple line values, and you would get a function that does something like this, where anything below or anything to the left would be below the x-axis because you would be in a negative profit, and anything above the x-axis would be positive. So that's how we could look at it in terms of profit. All right, let's look at a few examples here and see if we can follow this. This first one is pretty straightforward. So a firm has weekly fixed costs of $40,000 associated with manufacture of purses that is $15 per purse to produce. Those two pieces of information tell me about my cost function. So remember, the cost function is always your variable costs, which in this case is $15 per purse, and we're going to produce X purses, and then the fixed cost is $40,000. Okay, so, and we're just going to make a little reminder over here that where X is the number of purses sold and produced, it's always the same. Okay, so now if we look at our revenue, it continues to say the firm sells all the purses it produces at $35 per purse. So the revenue function is going to be $35 per purse, and you're going to sell X number of purses. We need to find the break-even quantity. So the break-even quantity is really just the X value that we're looking for. Like, how many purses would you have to sell in order to break even? We can talk a little bit further about, okay, well, what would the Y value represent? So let's solve this problem first. So finding the break-even quantity, since I'm given revenue and cost, what I want to do is set these two equal to each other. So where does revenue equal cost? Where are these two the same? This is kind of like substitution, if you will. So we know that revenue is 35x, and I know that cost is 15x plus 40,000. Fix that real quick, please. Okay, so 15x plus 40,000. Okay, so I'm going to subtract 15x from both sides, so that tells me that 20x then is actually equal to 40,000. And now divide both sides by 20, and we get that x is equal to 2,000. So that right there is the break-even quantity, the X value. This is the break-even quantity. So what does this mean? This means that we have to sell 2,000 and produce, if you want to put that, sell and produce 2,000 purses to break even. Okay, well now you might be wondering, okay, great, so that's how many purses we have to sell. I wonder what the revenue would be, or what the cost would be if we sold that many. So you could do one of two things. You could find C of 2,000, and that would be where you put 2,000 in for the cost function, or you could find R of 2,000. And I think finding R of 2,000 is a lot easier because it's just 35 times 2,000, and I know that 35 times 2 is 70, and then I would annex these 3 zeros on here. So I know that I would have to realize a profit of $70,000, not a profit, I'm sorry, realize a revenue of $70,000 in order to break even. So we would have the revenue would be $70,000. So we have to sell 2,000 purses and make $70,000 in order to break even. Kind of cool. All right, let's look at this one. This one's a little more complicated. And this one says the management of Raintech Irrigation must decide between two manufacturing processes for its Model A sprinkler head. The total monthly cost of the first process is given here by C sub 1. So C sub 1 tells us that we have variable costs of $20 per item and fixed costs of $10,000. X is the number of sprinkler heads produced and sold. The total monthly cost of the second process is C sub 2, and that is 10x plus 27,000. So when we compare C sub 1 with C sub 2 over here, I see this one has higher variable cost, 20 compared to 10, but C sub 1 has lower fixed cost, and that's the 10,000 compared to 27,000. So if we look at part A, it says if projected sales are 800 sprinkler heads at a unit price of 40, which process should the management choose in order to maximize the company's profit? Okay, so you could do this a number of different ways. What I'm going to choose to do on this one is I know that 40 is the selling price. So that is going to tell me over here, I'll write it in black, that the revenue function is 40x. All right, so if we start finding the break-even point then with that revenue with the different C sub 1s, let's see what happens when revenue is equal to C sub 1 of x, and then we'll figure out what that means. So when is 40x equal to 20x plus 10,000? Subtract 20x, so that's going to be 20x. When does that equal 10,000? So what does this one mean? This one, then, when we divide by 20, it's going to be x is equal to 500. So if I use C sub 1, I have to produce and sell 500 sprinkler heads to break even, to make no money. Anything over 500, I would realize a profit. So when I look at the sprinkler heads for 800 here, it looks like I would realize a profit when I actually have C sub 1 of x, because 500 is my break-even point. All right, let's look at the same thing over here with C sub 2. So R of x, when does that equal C sub 2 of x? So when does 40x equal, what are we dealing with here, 10x plus 27,000? So that would be 30x is equal to 27,000. When I subtract 10 from both sides and now divide, we get x is equal to 900. So that tells me I have to make 900 in order to break even with C sub 2. Well, if I have 800 as my projected sales, but 900 is my break-even point, then with C sub 2, I'm going to realize a loss. So it looks like in this instance that the management, I'll type this up over here in the corner, the management should choose do this as C sub 1 of x so they exceed break-even quantity. Break-even quantity is 500 with C sub 1, and we have sales predicted to be 800. You could also, guys, for this one, find the profit function for each of them and then plug in 800 and see which one gives you more profit. We're going to look at that actually a little bit here with part B. So which process should management choose if projected sales are 1,500 units? Well, if I look at it in terms of break even up there, I've got 500 and 900 as break even, and 1,500 will exceed both of those. So I'll get a profit with both of them if I use 1,500, if I sell 1,500 units, but which one's going to give me a bigger profit? That's what we need to find out. So what we want to do here then is find P sub 1. Let me get a pencil. So P sub 1 of x, that's going to be the profit function when I use C sub 1. So I'm going to say this is R of x minus C sub 1 of x, which is going to give me 40x minus the quantity. C sub 1 was 20x plus 10,000. Let me put my x right here, sorry. So this is going to be 40x minus 20x. I can do that. That's just going to be 20x. So this will be 20x minus 10,000. That's p sub 1 of x. Let's find p sub 2. That's the profit function when I use the second cost equation. So that's going to be r of x minus c sub 2 of x. R of x is 40x. C sub 2 is 10x plus 27,000. So this is going to be 40x minus 10x is 30x minus 27,000. So that's my profit using the second cost equation. So what we want to do, what we want to do, think about what would I do now in order to figure out which one realizes a larger profit. Well, what I want to do is substitute in 1,500 into both of these. So p sub 1 of 1,500. That means put 1,500 into the profit function that we found for p sub 1. So that's going to be 20 times 1,500 plus, I'm sorry, minus actually, isn't it? Minus 10,000. All right, when we do that, p sub 1 is going to give us, I believe, if I calculated it correctly earlier, $20,000. If we use p sub 2, same idea, p sub 2 of 1,500, so we're putting 1,500 in for p sub 2, so it'd be 30 times 1,500 minus 2,700, that should give us 18,000. 20,000 is larger than 18,000, so in this instance then we would want to use, I'll type this up in red, for this one, management should use c sub 1 of x, because they're going to get, what, $2,000 more in profit. So both do realize a profit, but you get more profit with c sub 1. All right, so you probably now can be thinking about, well, what am I going to do for part C, which is if projected sales are 3,000 units. So in this one, you want to find p sub 1 profit function when I substitute in 3,000. P sub 1, when I substitute in 3,000, if I calculated it correctly earlier, I get 50,000. And if you use P sub 2 at 3,000, we get 63,000. So on this one, because 63,000 is bigger than 50,000, management should use C sub 2. Because they will get $13,000 more if they do that. Okay, that does it for break-even analysis. You now have a quick assessment on break-even analysis.